Hey guys, welcome back to another Minecraft tutorial. Today we're going to do Physics 1 Lab 4. The purpose of this lab was to observe the motion of the mass oscillating on a vertically placed spring. Um, Physics principles used: the period of spring oscillation, the spring force equation for the stretch, and then the energy principles to get the delta energies, and then the velocity updates for and the position updates. I use the GlowScript model and the tracker model for the observed values. Then brief preview: things oscillate on a spring system. So the period of oscillation for a spring was used to get the K value, and using the K value we can get the stretch, and then using the stretch and the K we can get the potential energy of the spring, and then the potential energy of G is given by this formula, which is mg change in height, and then the kinetic energy of the ball is just going to be 1/2 the mass of the ball and the velocity of the ball. And then Newton's second law was used for A and for the velocity updates. So GlowScript was used to get the model, and then the ideal path of the mass, and then the predicted path was given by, or like the observed path was given by tracker. So I used the previous principles to get this, and then the energy graphs were used to see if energy was leaving or entering the system. It was not. If objects are in simple harmonic motion, then the spring constant can be determined, and then the tracker model is used to observe the x and y data points of the observed values. So the system contained the mass of the ball, the spring, and the earth, because they can all have energies. And then the air does work on the ball, so it can cause a drag by causing a drag force. And then the initial conditions: the ball should be pushed with 0 velocity, and there should be a stretch in the spring. And then the mass of the ball is 0.402 kilograms. And then the length of the spring with the mass is going to be 0.7 meters. So with the force of gravity pointing down. In the experiment, you should place the spring vertically from the ceiling, and then stretch the spring with the ball placed on the end, and then release the ball. Record the position per frame that the ball oscillates, and then make a model to predict the path and the energy of the ball. So in the code, this is before the loop. We have the delta t given, G is given, and then using the period of oscillation, we got the spring constant, and then the equilibrium position of just the spring is this, given by the force of spring. So then L is going to be the length of the spring at different positions, and then L hat is just going to be the unit vector of the length of the spring, and then the S is going to be the magnitude of the length minus the equilibrium position. And then using the physics principles, we can get these equations. And then we have storing variables for the previous energies, and then F gravity is going to be equal to this vector with the force gravity only pointing in the y direction, and then the spring force is going to be given by this equation. The net force is going to be the spring force plus G, or Fg, and then the ball velocity update formula is going to be the net force divided by the mass times delta t plus the initial velocity. And then the same thing with the position, just with the position and velocity instead. And then these values are the same as before with just updated values. And then the energy are going to be the calculated with the updated values, and then the delta energies are just going to be the final energies minus the initial. And then so after we get that, we see that the yellow line up here represents the delta E, so it's 0, so there was no change in energy in total. So similarities and differences between the experiment and the model. So the period is almost the same for the X and the Y. We can see that with the peaks. And then the peaks and the troughs align close to each other. And then the total energy is constant, as said before. The difference is that the magnitude is slightly off, and this can be due to errors. I might have misclicked on the tracker video, and the calibration tool might be slightly off. So that's why we get these differences. So what does this mean? Because the total energy remains constant, the energy principle is satisfied. When the potential energy of the spring decreases, the potential energy of potential energy of gravity increases. In the model, no work is being done. In real life, resistant forces do work, like drag and friction. The period of oscillation for the x direction was 1.65, and it was the same for the y direction. This makes sense because it follows a period of oscillation for a spring. Thanks for watching my video. Have a good day.